Hello everybody, this is Tiziano and today we are finally get to land on an Aruco marker. If you're new to the channel, consider subscribing because I'll be posting content about robotics, programming, drones, computer vision right here. And at the end of this video, there's gonna be a shout out for a follower of mine who got inspired by this channel and is gonna start his own startup in the future. So stick with me up to the very end because you might be my next shout out. In part 1 of this precision lens tutorial, we developed a script who would detect the marker and estimate the camera pose and the marker pose. If you haven't seen it yet, just follow the link in the description below. In this tutorial, I'm gonna show you how I converted that script into a library so that we could recall it later. Then, we're gonna develop together a simple script that would connect with the vehicle, call the function to detect the marker, and then fly over the marker and land on it. To be fair, there are other ways for accomplishing the same task, but this tutorial is gonna be very simple, just following the following 7 steps. Step 1, we detect the marker and we get its location in camera frame. Step 2, we convert the location from camera frame to body frame. Step 3, we convert the location from body frame to northeast frame centered on the UAV center of gravity. Step 4, we obtain a marker's location, latitude and longitude by adding the northeast to the current vehicle's location. Step 5, we command the vehicle to go to the marker location. Step 6, we command the vehicle to fly over the marker, and if the error is low enough, we also command it to descend. Step 7, when the altitude is low enough, we command the vehicle to go to land. And the great thing is that this time we're not gonna simulate it where we're actually gonna fly on a real system. We are gonna actually use this setup, very simple, Raspberry Pi 3 and a down-looking camera, Velcro. Very simple setup. We are experts, we had so much fun at the flying field. You're gonna see in the video, it's gonna be awesome. And now, enough with the talking and follow me in the next tutorial. Now, the first thing we're gonna do is converting the script that we developed in our first video into a library, creating a class, and we're gonna call this class Aruco Single Tracker. And we're gonna pass the ID and the marker size, and then the camera metrics and distortion. And then we set the camera size and we set the default 640/480. So let's explore the whole class all together. Here we have rotation metrics to Euler, the same function as we had in the script. 2 extra functions that are update FPF read and update FPS detect for the overall performance. Then we have just a stupid stop function that it's just gonna set kill to true, because the next function track can be a loop or not, and because we have an infinite while loop until kill is true. In this loop, we just read the camera as we did in the script, and then we update the frame per second read. And here as before, we convert in gray, and then we detect the marker. In the end, if this function is not called as a loop, we return the flag marker found, and XYZ are the location of the marker in camera frame. And here at the end of a file, you can find a test function. This library works exactly as the script I developed in video number 1, but has the ability to be called as a library. So we start by importing system path, and we're gonna append the current directory to the system path. Then we import the usual time, math, and arc parse, and of course drum kit and py-mavlink. We're also going to import our library Aruco pose from opencv.lib_aruco_pose. We're going to import everything with the star. Then we just parse the input arguments, and we just use connect as the only argument, and args is the parsing arguments. Now let's define a function for increasing our location with a delta north, delta east in meters. We're going to calculate the delta latitude and delta longitude respect to the current latitude position, assuming the ellipsoid model. And then we're gonna return the new latitude and new longitude added to the current location. Next, let's define a function. This function is gonna convert the reference frame from camera to UAV. Now the camera has the x-axis point right and the y-axis point down, so I'm assuming that the camera is down looking. X of the UAV equal to negative the y of the camera, and the y of the UAV equal to the x of the camera. Now we define a function UAV to northeast that converts a vector from UAV body frame to northeast, just rotating by the yaw in radians. Next, we're going to create a marker position to angle. This is pretty useful. We just estimate the angle of the line of sight of the current marker with respect to the center of the drum. And we're going to be using later for understanding whether the error is within a certain value so that we can descend. And now it's time for the main loop. The main loop is very easy. What we're going to do, we're just connecting with the vehicle using the arguments, the input arguments. Then we just define a couple of parameters, the radians to degrees and degrees to radians. And then here we define the marker that we want to track and its size in centimeters. And the frequency, we want to send the update to the autopilot. Then let me define the altitude under which we're going to set the vehicle to landing mode. And the angle descend is the angle within which the vehicle will descend, and is commanded to descend at this speed, descent speed centimeters, and we're going to set it to 30 centimeters per second. And now we have to read the camera matrix and camera distortion. So here I just save in CWD the current path, and I'm gonna get the camera matrix and camera distortion file relative to the current directory. Then I define the Aruco tracker object. And now the while loop. The while loop is very simple. We're just gonna call the track out of the Aruco tracker object, and we're gonna return whether the Aruco is being found or not and its position. And then if the marker is found, we convert its coordinates into UAV frame, and then we obtain the UAV location from the vehicle, and we save it into UAV location. And then, just to prevent any error, if the system is higher, is too high, it's hard to detect the current distance from the marker, then we're gonna say that if the altitude is greater than 5 meters, then the zeta in centimeters is equal to the altitude, the barometric altitude in meters, multiplied by 100. And now we just estimate the angle X and angle Y, that are the two angles in body frame. Then if it's time to send a command, what we do, we convert the coordinate into northeast frame, and then we estimate the marker latitude and marker longitude that they come from the UV location plus the delta north and delta east. And now, if the angles are below a certain value, then the target altitude is going to be lower than the current UV location. Otherwise, we're going to keep the target altitude equal to the UV location. Then we create a target location object from the location global relative function, passing the latitude, longitude, and the target altitude. And then we just call vehicle simple go to, passing the target location. Last thing we want to do is that once we are below a certain altitude, we just want to set the vehicle into landing mode, only if the vehicle mode is guided. Oh no, they lost it at the very end. Oh, it's fighting! Yeah! Oh, I got it! So, how cool was that? We proved that even an algorithm as simple as the one that we just developed could actually work in real life. And yes, that drone was powered from the ground. We used a power supply that comes pretty in handy when you have to develop code for a long amount of time. And now, why don't we do a little bit of a challenge? Why don't you guys develop your own version, you submit the video, and the best one is gonna be part of my next shout out. And talking about shout-out, this one is dedicated to Vibhu Tripathi, an Indian student whose team in August 2018 won almost $1,700 participating to a drone challenge where they developed a drone delivery system. They got inspiration by this channel and they thanked me a lot. So keep up the good work, guys, and I know, Vibhu, that your next startup is gonna be a success. Keep us posted. And now you guys, if you wanna follow me even on Twitter, my account is tfiorenzani, and on LinkedIn and Facebook is Tiziano Fiorenzani. And also, don't forget to check out our company Axworks. You're gonna find the link in the description below. Thank you guys for watching. Don't forget to subscribe, and I'll see you next time.